Okay, in lesson 7.7, day 2, we're working on word problems. As we're dealing with quadratic equations in this chapter, all of the word problems, you will, step 1, need to write a quadratic equation. And then step 2, we'll be talking about finding the maximum or minimum of something. So that makes sense that we'll be talking about parabolas then, or quadratic equations, because the vertex always is a maximum or minimum depending on which way the parabola is facing. So there are a few formulas that you need to memorize for this. One you already know. So for any quadratic in general form, ax squared plus bx plus c, we can find the vertex, which is hk, that you know. But here's the new formula. We can find h by computing negative b over 2a, and then we can find k by taking whatever answer we get for our h and plugging it back into the original function. So in function notation, I'll write that as f of h. And you'll see how to apply that in the next examples. Okay, so the question here really is, the sum of two numbers is 30, and if one number is x, then the other number is blank. We'll figure that out. Their product is p. We'll write an equation for that as well. So they say find the maximum value of p. And when we say p, we're referring to the product. So basically the sum of two numbers is 30. Find the maximum value of their product. Okay, so let's first define some variables. So it already said that x is one of the numbers. So then we know the sum of their numbers is 30. So let's say we call y that other number. So we know then x plus y equals 30. So then to answer this second part of the question here that says, then the other number is blank, well, let's write an expression for y in terms of x. And that just means take this equation and subtract x from both sides. So the other number is 30 minus x. That makes sense. Whatever's left over from 30 will be the other number. So then it says their product is blank. Well, let's multiply them together. So we have x times the other number, which we just said was 30 minus x. Okay, but now we want to find the maximum value of their product. So the first thing we want to do is write a quadratic equation for the product. So product, we're calling it the function p of x. We've basically already done that here, but let's go ahead and write it in general form. So p of x equals x times 30 minus x. So that's, if I distribute, I'm going to get negative x squared plus 30x. So that's step 1. Write a quadratic formula for that value you're trying to represent, which in this case is the product. So step number 2 is then to find the maximum. We know the maximum is going to occur at the vertex. So we're going to use those formulas I gave you on the first slide. We can find h by computing negative b over 2a. So looking at our formula here in general form, we have the a is the coefficient here, so negative 1, and b is the coefficient here, so 30. So we'll get negative 30 over 2 times negative 1. So that's 30 divided by negative 2, or 15. So what we've done here is find the x coordinate of the vertex. We still need to find the y coordinate, because the y coordinate is that actual maximum that we're looking for. If you think about plotting that point, the y coordinate tells you how high you are on the graph, so that will be the maximum. We get that using the k. What the k says to do is go back to this equation that you wrote, and now in place of x, substitute what you just got for your h value. So that's 15. So we'll do that, and we'll get 225. So that's our y value, or our maximum. So to answer this question, the maximum value of the product is 225. Example 2 says the difference of two numbers is 20. If the smaller number is x, we'll again write an equation for the other number. Then we'll write an equation for their product. Now it says find the minimum value of p. So this problem is very similar. First of all, if we call x one number, y then is the other number. This time, the difference of those two numbers is, what does it say? The difference of the two numbers is 20. So if I take the difference of the two numbers, I'll get 20. So let's write an equation for the other number, which is y. We can add x to both sides of this equation and get 20 plus x. Okay? So then their product, if I write an equation for their product, this is the part where we write the quadratic. If I multiply together x and 20 plus x, then I'm going to get the quadratic equation x squared plus 20x. Now I kind of forgot to mention this on the first slide. It helps if you kind of visualize this. This has a coefficient of positive 1. We know that means that it's a parabola that faces up, whereas the example before faced down. It makes sense to me now that this equation has a minimum value. The vertex is a minimum. On the previous problem, the vertex happened to be a maximum. Either way, we're still calculating the vertex. So we need our h and our k. To get our h, we use the formula negative b over 2a. Here we have b is 20, a is 1, so let's plug that in. Negative 20 over 2 times 1, so we get negative 10. Now to get our k value, which actually is the minimum because it tells us how low this graph is, we need to take our answer from h, which is negative 10, and plug it back into the formula that we wrote in place of the x. So we're going to have x squared times 20x, which means we're going to put negative 10 squared plus 20 times negative 10, and we'll get negative 100. So the question is find the minimum value of their product. So the minimum, here's my eraser. Minimum product is negative 100. Example 3. A rectangle has a perimeter of 56 feet. What is the maximum area? Okay, so let's draw a picture even though we don't know much about this rectangle, but we'll go ahead and define some variables. We'll call L the length and W the width. Okay, we know that the perimeter of the rectangle is 56 feet. Perimeter we know means adding up all the sides, so there's 2 lengths and 2 widths. Okay, but what we need to do is write a quadratic equation for the area. That's the first thing that we need to do. So we'll write an area formula. The area needs to be some sort of quadratic equation. Well, we know area is length times width. So what I need to do is write an equation in terms of one variable, either the length or the width. So what you're going to do then is solve this equation for one of those variables. So let's say I'm going to choose L. Solve for L. So if I solve this for L, the first thing I'm going to do is I'll go ahead and divide everything by 2. So I'll get, where am I here? 28 equals L plus W. And then if I subtract W from both sides, I'll get 28 minus W equals L. Now here's why that's useful. I'm going to plug that in for this L in the area formula here. So 28 minus W times W. Do you see now here that we're going to have an area formula that's quadratic and in terms of one variable when I distribute? So area is going to be negative w squared plus 28w. Looking at this coefficient of negative 1 here in front of our w squared, we know that we're going to have a parabola that looks like this, which means it's going to have a maximum value. Again, that just makes me understand that why they're asking for the maximum area. Okay, so step 2 then, the maximum occurs at the vertex, so we need our hk. H we can get by doing negative b over 2a. So in this case, that's negative 28 over 2 times negative 1. So we'll get 14. But that's only the x-coordinate of the maximum. What we really need to get for the maximum is the y-coordinate. So that's the k. K we get by going back to our area formula. I'm now plugging in 14 for all of our w's. So 14 squared plus 28 times 14. And in this case, I'll get 196. So for this problem, the maximum area is 196 feet squared. Okay, this last example, example 4, says the perimeter of a rectangular window is 32 feet. Find the maximum area. So very similar problem to the one before. I'm just going to do it one more time so you can get the hang of it here. So again, you'll define some variables. You have a rectangular window, that's length times width. This problem says the perimeter is now 32. So slightly different than the other problem, but basically the same exact process. So we're still trying to find the maximum area, so I'm going to write an equation for the area. Area I know is length times width, but I need to write that in terms of one variable, either L or W, because I need this to be a quadratic equation. So here, I can choose to solve this equation for either variable. We can either solve for L or W, doesn't matter. I'm going to choose to solve for L just because we did that last time. This problem works out pretty nicely too in that you can divide everything by 2. So I get 16 is L plus W. Subtracting W from both sides gives me 16 minus W. That's what I'm going to plug in for the L in the area formula. And then I'm going to leave W just W so that when I distribute, I have a quadratic equation. So area equals negative W squared plus 16W. Again, that makes sense. We got a parabola that looks like this. That's going to have a maximum value. We just need to find it. The maximum occurs at the vertex. That's our HK. So we find H by doing negative B over 2A. In this problem, that's going to be 16 for the B, negative 1 for the A. So we'll get negative 16 over 2 times negative 1. So that's positive 8. But that's only the x value of our vertex. We need the y value because that's what actually tells us how high this maximum is. The 8 just tells us where the maximum occurs. So to get our k, we go back to our area formula and plug in this 8 for your w's. So that's going to be negative 8 squared plus 16 times 8. And in that case, we'll get 64. So in this problem, the max area is 64 feet squared. Okay, this finishes up chapter 7, so this is 7.7 day 2. Check out that homework on Schoology, and then we'll start reviewing for the test after this.